Hi, folks. This time we are going to talk about rates of chemical reactions and fuels. So, the story so far, we've been talking about a lot about chemical reactions. We've talked last time about energy, kinetic energy, that energy of motion, potential energy, that energy of position, and that law of conservation of energy, that energy cannot be created or destroyed. It's just constantly changing from one form into another. This week, we are going to dip our toe into a little bit of what is the difference between organic and inorganic chemistry, what are hydrocarbons, the alkane series, what exactly is petroleum and fuels, and talk about what affects or impacts reaction rates, activation energy, and a little introduction to catalysts. Now let's start by talking about the difference between organic and inorganic chemistry. These are two huge divisions in chemistry. When you go forth and take more chemistry in your college career, there are whole degrees in both of these. So what are these two big categories? Before we begin, I want you to understand that the rules of chemistry apply to both. Everything we've done up until this point, bonding, writing reactions, balancing reactions, the types of reactions we've discussed, oxidation reduction, and that beautiful law of conservation of energy, all of that applies to both organic and inorganic chemistry. It's sort of as if you're looking at laundry, and organic chemistry is just looking at the socks in your laundry. Okay, it is a small fraction of everything that is in your laundry, and they're all clothes, you all wash them the same way, but it's just one small part. The definition of organic chemistry is the study of substances that contain the element carbon. And make sure you know that definition for quizzes, tests, and whatever. Now, if you recall from long ago, far away, we talked about the fact that carbon contains or has multiple pure forms that it comes in. And if an element comes in multiple pure forms, those multiple forms are called allotropes. In its pure form, carbon can come in graphite, diamonds, and all of these other fun shapes called Buckminster fullerene and carbon nanotubes and things like that. Why can carbon do this? Well, it's because carbon is a pretty amazing substance. Carbon can form 4 covalent bonds. And because of this really interesting fact that carbon is in group 4A or 14, and it can form these 4 covalent bonds, it has a really versatile chemistry. It can do a wide variety of things. And because of that, millions of carbon compounds have been identified, and more are synthesized, created, and discovered annually. Now, inorganic chemistry is chemistry that is everything else, substances that do not contain carbon. So that is water, all of the lovely salts that we've talked about, metals, metallurgy, rocks. A lot of geology involves non-organic things. Minerals, when we talk about rocks and minerals, minerals are those non-inorganic things. Those are all of the other things on the periodic table and their bonding. That is the inorganic part of chemistry. So what kind of things are organic compounds? Well, it was originally believed that if something contained carbon, it is alive or formerly was alive. That is no longer known to be true, but on planet Earth, we have a carbon-based form of life. So everything that is alive or formerly was alive on planet Earth does contain carbon. From the lowliest virus to bacteria, fungi, plants, animals, people, everything that is in the living biome of planet Earth contains carbon. Now, anything that makes up biologic systems, all of the building blocks of those plants and animals, are organic compounds. So these are the proteins, the sugars, the carbohydrates, the DNA, the blood, the lipids, the nucleotides. all of the bits and pieces that make up those plants and animals are carbon compounds. And I'm hoping you're starting to see what a huge field this organic chemistry can be, because carbon makes up so many vital and important molecules. It also makes up fuels. Everything from gasoline, diesel fuel, petroleum jelly, butane in lighters, the wood that you might have in a wood pile, kerosene, which is diesel fuel, or lamp oil. This is cow chips. I know, I was having fun finding pictures. Candle wax. All of these things are petroleum products, wood products. If we burn it for heat, it's a carbon compound. And so this is, again, big area of chemistry. In the last 200 years, chemistry has expanded its understanding of organic compounds, or these carbon compounds, and has been involved in synthesizing or creating in the laboratory so many of the molecules we depend on in our modern life. So these are the paints, the rubbers, the plastics, the fabrics, the fibers that help modern life exist. Odds are you are wearing some sort of a fiber right now, unless you are very diligent to avoid any synthetic fiber. It is very difficult to not be wearing something that contains some blend. The elastic in your underwear and the polar fleece that you have keeping you warm and snuggly, those are synthetic carbon compounds. Latex paint on your walls. Tires are not pure natural rubber. They're a blend of natural rubber plus synthetic rubber. If you recycle your plastic, all of the multiple different kinds of plastic that are out there that need to be recycled are different synthetic carbon compounds. The PVC in your plumbing, the rubber ducky you might have in your bathtub, the nylon hose that people don't wear as much as they used to, and the styrofoam cartons that you may have gotten your takeout order in, all of which are synthetic, meaning made in a laboratory, carbon compounds. Now, in the field of health, in the field of medicine, we're talking about a huge, big, massive, important field for synthetic organic chemistry, because medications, everything from the vital and important COVID-19 vaccine, insulin, birth control, flu shots, all the anesthesias, antibiotics, and gazillions of other drugs that make us well and keep us healthy are made in a laboratory, understanding the chemistry of the molecule carbon. Because our life is based on the chemistry of this element, it is a big, big deal. I also want you to understand that the term organic does not mean that it has been, something is not better or special or more magical if it contains carbon. All it means is that it contains carbon. It does not mean that it was produced by wood nymphs and fairies not involving any chemistry. And yet sometimes advertisers will bandy about and throw the word carbon, or the word organic out there, and make the impression or give the idea that it is an all-natural, fabulous, and wonderful thing. The Food and Drug Administration, outside of vegetables and produce like your meat or your eggs, there are no regulations about the use of this word, because the definition means contains carbon. So if it's food, it contains carbon unless you're drinking pure water. So to give you an example, all of these things are 100% guaranteed organic compounds because they all contain carbon. Nitroglycerin, diesel fuel, the COVID-19 virus, tar, and good old dangerous poisonous cyanide are all 100% organic because they contain the element carbon. Now, there is a huge difference, and some of you right now are getting all bristly with me because you're going, well, I only eat organic produce. Yes, there is a difference, and there's difference because only if you're talking about produce and meat and vegetables and eggs and milk, because if you have a certified organic farm, those farmers have had to go through very stringent protocols in order to be a certified organic farm. But anything beyond produce, please buyer beware. Please be smarter than the average person out there. If you have organic body lotion, all it says is it contains carbon. It does not say anything about it being extra magical or extra special. Because remember, cyanide and diesel fuel are also 100% organic. So remember, organic means contains carbon. There are millions and millions of carbon compounds, very, very important to life, medicine, and everything you and I do. Inorganic means that it does not contain carbon. Again, millions of compounds, also very important to what we do. And one more example that I want you to understand. Many people take vitamin and mineral supplements, and many people attempt to get their complete servings of vitamins and minerals through the food that they eat. But if you look at the back of a vitamin and mineral packaging, I want you to understand the organic versus the inorganic. The minerals, those are the inorganic trace metals and elements that you need. So these are going to be the chromium, magnesium, copper, selenium, zinc, iodine. These are the inorganics. The vitamins are large organic molecules that the only source are from plants and animals. This is vitamins A, C, D, E, K, thiamine, riboflavin, niacin, folic acid, biotin. These things are organic. So your supplements are going to be a combo of both organic and inorganic molecules. And you've been through chemistry now, so you're smart and you know the difference between the two. All right, we will see you later. Bye-bye.